We might expect Mars to have seasonal cycles similar to those on Earth. After all, Mars is a planet that orbits the same star and is a rocky planet with a similar distance to the Sun and an axis of rotation with an inclination very close to that of our planet. So, all the conditions for having similar seasonal cycles are there. Yet, the seasons on Mars have some complications that make exploring this topic particularly fascinating. We'll discuss this in this video. Welcome to our channel. Today, we'll be talking about the seasons on Mars. If you're interested in these topics, please subscribe to the channel and hit the bell icon so you don't miss the upcoming content I'll be publishing. That said, let's move on to the seasons on Mars, which we find extremely fascinating for one main reason. They help us understand how a planet's orbit and the context in which it moves can significantly influence what happens on its surface, especially regarding such an important aspect as seasonality. However, let's start with what we know about Earth, as it's something we are obviously more familiar with and can use as a basis for comparison with the red planet. Essentially, the seasons on Earth are due to a single factor: the tilt of the Earth's axis of rotation. The Earth rotates on its axis, which is tilted at 23.5 degrees relative to the plane of the ecliptic, the plane on which the Earth and other planets orbit. The fact that there is this tilt, which remains fixed throughout Earth's orbit and the entire year, means there are times when one hemisphere receives more energy from the Sun than the other. This happens because, with this tilt, one hemisphere of the Earth is oriented towards the Sun while the other is tilted away, leading to the Sun transferring more energy to one hemisphere than the other. This is something we all experience, for example, in the summer season when the Sun stays in the sky for more hours. This means that the arc it draws in the sky is larger than in the winter season, and, consequently, the Sun transfers more energy to the Earth. If it stays above one hemisphere for more hours, it means it stays above the other hemisphere for fewer hours, where it is winter. This is the root of the seasons: how much time the Sun spends above one hemisphere and how much energy it can transfer to one hemisphere over the other. There are times when this difference is greatest, like during the winter and summer solstices, and times when it is minimal or non-existent, such as during the equinoxes, when both hemispheres receive the same amount of energy and then switch roles. The Earth's axis of rotation is fixed at 23.5 degrees thanks to tidal interactions with the Moon, which acts as an anchor maintaining the stability of the axis's tilt. Another factor that could influence seasonal cycles is the eccentricity of the orbit. Since Kepler's time, we know that planetary orbits are not perfect circles but ellipses, slightly squashed circles. This means there are times of the year when the Earth is farther from the Sun, aphelion, and times when it is closer, perihelion. We would therefore expect the Earth to receive more or less energy depending on its position in orbit, and it does. At perihelion, we receive more energy than at aphelion. However, Earth's orbit is almost circular, with only a 4% difference in distance between aphelion and perihelion, 147 million kilometers versus 151 million kilometers. This variation is negligible concerning the formation of seasons, mainly because other factors, such as the different distribution of land and oceans between hemispheres, play a role. Ultimately, the primary cause of seasons on Earth is the tilt of the axis of rotation. Now, let's move on to Mars to see what happens on the red planet. The seasons on Mars differ from those on Earth. Although there is a component related to the tilt of the axis of rotation, very similar to that of Earth, 25 degrees versus Earth's 23.5, the eccentricity of Mars's orbit is much higher. Mars moves on an orbit with a significant difference between aphelion, 1.66 astronomical units, and perihelion, 1.38 astronomical units, about 0.3 astronomical units. This difference significantly affects the duration of Martian seasons. Spring and summer in the northern hemisphere of Mars last 199 and 181 Earth days, respectively, while autumn and winter last 145 and 160 days. This variation is due to the speed of Mars along its orbit, faster at perihelion and slower at aphelion. Additionally, the seasons on Mars are influenced by the distance from the Sun. At perihelion, the southern hemisphere of Mars is in summer, making this season warmer than summer in the northern hemisphere. Winter in the southern hemisphere is also colder than winter in the northern hemisphere, causing the atmospheric carbon dioxide to freeze into seasonal polar caps. Another aspect to consider is the presence of dust in Mars's atmosphere, which affects surface temperatures by trapping heat. This dust can cause significant temperature variations, influencing cloud formation and temperature distribution. Finally, Mars's axis of rotation varies significantly over time, from 0 to 44 degrees, due to the absence of a large stabilizing moon like Earth's. These variations affect the distribution of ice and the planet's seasonality. In summary, the seasons on Mars are a complex and fascinating subject, with numerous factors at play that make the planet's climate unique. Thank you for watching the video until the end. We invite you again to subscribe to the channel and activate the bell. See you in the next content.